I'm Petra. I'm working as a forecaster here in Zagreb at Croatian Met Service. And this slide, this presentation, actually I have prepared together with my colleague, Tanja Renko. Today she is on shift, so unfortunately she cannot be today with us, but I will be free actually discuss with you situation across the Europe, but also I will show you some very nice weather phenomena that happened at the beginning of the November. So let's start. That's Zagreb in the morning. Actually, the view from my window in the office. As you can see in the morning, at 6 UTC in Zagreb was partly cloudy. Now we have more sun, as I can see, and it's already 9 degrees, but in the morning at 6 UTC in Zagreb was -1 at 2 meters and -5 Celsius near the ground at 5 centimeters. So if you look carefully here on the grass, you can see frost. So this white frost. And what was very interesting today in continental part of Croatia, that at Sljeme, that is peak at the Medvednica mountain. This mountain is actually near Zagreb. You see these hills here, so that is actually the Medvednica hills. And there at around 1,000 meters was already at 6 UTC 5 degrees. So we have very nice, very pronounced temperature inversion. And during the cold part of the year, so especially at the end of the November, in this kind of situation, you will expect some fog. But as you can see here, we don't have actually foggy weather in the morning in Zagreb. That is because we have the mixing due to southwesterly wind. In the high terrain, the wind speed was between 5 and 10 meters per second, and even at Sljeme we have some gale wind gusts, so around 17 meters per second. Because of that, we don't have fog or stratus in Zagreb. But if you look at the other part of the continental Croatia, so where we have not so strong wind, so the wind was weak in the morning hours, then you can see some low clouds. If you look at 24 microphysical RGB product. So here I mark that with the arrow. So you see this color, something like light yellow color, actually indicate at the 24 hours microphysical RGB low-level water clouds. Of course, we cannot be quite sure if you look just at the satellite image if that is fog or just stratus. You know that the satellite product actually give us just information about the cloud top. But let's look at the sign of measurement. So here in this region of Croatia, in this continental part of Croatia, really we have fog, a very dense fog, and also right here in the mountainous part of Croatia, also some fog, pretty dense because the visibility was lower than 200 meters. So in the morning, where the wind wasn't so strong, we really have the foggy weather also in the Croatia. Okay, now I'll give you actually a brief overview about the weather in my region. So before we start with the synoptic analysis about Europe, can you please tell me where are you from? Where are you now? Okay, we have a lot of people from Central, Eastern Europe, and also from the British Isles, so from England. Nice. We don't have any from Western Europe, but okay. Thank you very much. Okay, thank you. Let's start with the analysis of the synoptic situation across the Europe. So I really like to do that with the Airmass RGB because this RGB really give me a lot of information about the synoptic situation. So we very nicely see the distribution of cold and warm air masses. Also, we can see the cloud bands and, of course, some dry air masses. But firstly, in this greenish color, we can nicely see this warm air mass here in the southern part of the image, and also this warmer air here on the western part of Europe. And of course, here in this I can say violet and blue colors, we can see this very pronounced cold air. Here we have these cloud bands between at the border between the warm and cold air mass. And here I want to ask you, I hope that now we will not have problem with my mouse. I want to ask you to mark the region where you see the dry air intrusion, so the dry air mass. You're all focused on the European continent, but we have also something right here at the Atlantic. Very nicely, we see here the maximum of the dry air intrusion. Yes, you do it very, very good. Very nice. Thank you. Thank you all. Again, okay, thanks. Yes, of course, the dry air masses, the dry air intrusion is represented in at Airmass RGB in this brownish, reddish color, and you all very nicely detected this region. So we have here very pronounced actually line of this dry air mass. Also here very nicely we see this brownish reddish color, like some circle actually that can be the maximum also in the PV. Here also we have some dry air, and also here over the Atlantic. Here we see something that also show this dry air intrusion. It can be something that like upper level low or something like that, but usually this brownish reddish color nicely coincide with the PV, so we can check the PV unit between 1.5 and 2. You can see very nicely that here when you have this brownish and reddish color, you have also the PV between 1.5 and 2 units. And also here we have a very nice actually maximum in the PV anomaly. So here also we have very nicely pronounced actually the cyclone, so the surface low. The another low is right here, and here we have one cyclone. That was the cyclone Alexis that brings some extreme weather in the southern part of Italy yesterday and the day before yesterday. Now the cyclone Alexis is in the dissipation stage, but you will see later that we will have actually we'll get another cyclone that will develop in the Adriatic Sea and already got a name. I will tell you that a bit later. Also, I want to say that this dry air intrusion or dry air mass very nice coincide with the jet streams. So if you overlaid the isotype at 300 hectopascals, you can nicely see also this jet stream right here, where you have this line of reddish and brownish color. We have also some jets here connected with this nice cyclone over the Atlantic Ocean. So if we look at the mean sea level pressure, then you really see this nicely cyclone center here. So in the northern part of Europe, we have a very, very pronounced cyclone with very cold air, and in the upper layer, very, very pronounced actually trough with a cold air advection, and this strong pressure gradient give us actually is a sign that you will have a very strong gale wind in this region. Also, of course, another cyclone that is very nicely seen on the Airmass RGB is this above the Atlantic Ocean, the another one right here, and this cyclone Alexis that already is in dissipation stage. But today, actually, the most severe weather will be right here, where we have very, very strong pressure gradient, and the dominant threat here will be, of course, very strong and gale winds. So if you look at the meteor alarm, you can see that here in the central part of the Europe and this Denmark also, we have actually lots of warnings, usually the warnings for strong wind in yellow or orange level. So that is actually the main threat today in the Europe if you look at the whole synoptic situation. But first, I want to ask you, if you look at the 24-hour microphysical RGB, can you detect, actually mark some fronts here on this RGB satellite product that is accompanied with this cyclone that we already analyzed? Can you mark some fronts here on 24 microphysical RGB? So you know that we have a very, very pronounced cyclone here, yes, on the southern part of Europe. Okay, nice. Nice, yes, yes. Okay, very good. So we have one front right here that is connected with this very, very pronounced and deep cyclone in the northern part of Europe. And also this front here that is the occlusion front, and this here is actually the cold front. We can look briefly here on the Deutsche Wetterdienst frontal analysis. So you can see this long cold front. Here is a bit warm front, and this very nice wavy, I can say, occlusion front. And of course, we have some fronts here that is connected with this very nice cyclone over the Atlantic Ocean. But let's concentrate on this one over the European continent, because today we will already have a very strong, actually extreme weather and potentially severe weather in this central and northern part of Europe. So usually the main threat will be wind, and in weekend during the weekend, we will have also some extreme situation, especially in the southeastern part of Europe. As I told you, these fronts will moving through the southeast, and right here in the Adriatic Sea, a secondary low will develop. This cyclone that will develop in the Adriatic Sea already got a name. The name is Bettina. So the cyclone Bettina will bring also a very cold air and some rain, even a snow in the southern part of Europe, here in Italy, and also Croatia, Bosnia and Herzegovina. And also it will be even stronger when this cyclone will intensify in the southeastern part of Europe. So here over the Bulgaria, Romania, with the center over the Black Sea, you see that on Sunday you will have a very, very pronounced low. So also with a very strong gradient, with a lot of moisture. And here we expect some really extreme weather due to that cyclone. If you look at the upper level chart here, you can see a very pronounced thermodynamic trough, thermobaric trough with very, very cold air. So the polar air mass just will get here to the southern part of the Europe, and really in this part of Europe, in the Bulgaria, Romania, southern Serbia, Kosovo, you will have northern Macedonia, you will have a very very extreme weather, because if you look at the ECMWF accumulated snow, you see that here we have a significant amount of snow cover. So more than, in some region, more than 50 centimeters of new snow, especially in Bulgaria. I think that Bulgaria already for that day is issued red warning for snow. If we have someone from Bulgaria, please type in chat if that is true. But I actually checked that in the Meteor Alarm web page. So they already actually had issued a red warning for snow. I hope that you will not have some great damage or big damage or some extreme and potentially dangerous weather, but it looks very, very severe and strong because this cyclone is very deep. It has a very high pressure gradient, and if you look at the ECMWF wind gust speed, you see that you will have also some gale wind gusts, and together with this amount of snow you can have also a blizzard. So that is very extreme situation in the southeastern part of Europe. With that, and I will finish today actually analysis, and I will also give you a briefly overview of another extreme situation that happened at the beginning of November. So that is cyclone Ciarán. I hope that I pronounced that well. This cyclone Ciarán has started its life cycle over the Atlantic Ocean, of course, and it was one of the strongest storms that hit European continent in recent time. It both really extreme and severe weather conditions. So hurricane force winds up to 200 kilometers per hour, heavy rain, some record amount of rain. But unfortunately, I have to say it caused at least 7 casualties, and it was dozens of injured. So unfortunately, that was very, very strong and very severe. Also, I want to mention that more than 1 million homes were without electricity on that day. Very interesting and not so common was that in Jersey, on Channel Islands, was recorded 5 centimeters hailstones, and also a tornado. The tornado path was around 8 kilometers. So that was actually a low top supercell that developed in a low cape and very strong wind shear environment. So the wind shear was between 25 and 30 meters per second, and in such environment probability for 5 centimeters plus hailstones is only 1 or 2%. So it was very extreme and uncommon behavior of such deep moist convection. I want to say that that was a very, very nice example of rapid cyclogenesis. Of course, more about mechanism of rapid cyclogenesis you can find on EUMeTrain webpage in Satmanu. And what is also very interesting to stress out that this looks like a Shapiro-Kaiser cyclone, where we have a very strong deepening of the surface low. So in case of rapid cyclogenesis, you have a rapid development that takes place here in the left exit region of jets. And in case of classical cyclogenesis, through wave development, the production of cloud spiral is often slow. So the spiral is produced after some days, but during this rapid cyclogenesis, the development from this cloud head, as you can see here, to cloud spiral is within 12 hours. And also it is important to emphasize that after the mature stage of this kind of cyclone, it is no longer any notable difference between these two processes, so between classical and rapid cyclogenesis. Also, life cycle of rapid cyclogenesis, as well as Shapiro-Kaiser cyclones, you can very nicely monitor on Airmass RGB satellite product, where you can recognize 4 typical stages. So as you can see here, that is the wave stage, the intensification stage, mature stage, and dissipation stage. Of course, at the first, in this wave stage, the cold front develops at the boundary of cold and warm air masses. And in wave stage, you can clearly recognize so-called cloud head. In the reddish color, you can see a very, very pronounced this jet stream and dry air intrusion. Now, in the intensification stage, often develops very quickly, as I told you in the slide before. And here in the mature stage, the cloud spiral is nicely developed. In the dissipation stage, you have very, very pronounced this cloud spiral and dry air mass in this reddish color. So you can very nicely that monitor on Airmass RGB. Let's look at our example, at our cyclone Ciarán. So this can be actually the wave stage. Here we can see something that looks like a cloud head. Here in this intensification stage, you can very nicely see this development of cloud spiral. Here is very, very nicely developed this cloud spiral and this very nicely pronounced dry intrusion. You see also in this cold air some open and closed convective cell. And also in the dissipation stage, you can see very nicely and pronounce this cloud spiral and also this dry air mass in this brownish reddish color. So really it looks very nice on the Airmass RGB. Now I want to show you the animation to see actually how it looks like from the beginning to the end. Just look here on the Atlantic Ocean and you will see firstly the cold front. Here is the cloud head spiral, and now, wow, very nice cloud spirals here. Maybe you can see some this like line cloudiness, so some lines that can be the sting jet that actually produced a hurricane like wind. So very, very intense phenomena. Also, it is very nice to look the development of rapid cyclogenesis on the water vapor 6.2 micron, because in this you can very nicely see actually this dry air mass. Just look here on the Atlantic Ocean and you will nicely see this dark color, so that is very, very pronounced dry air here and you see this dry air actually wrapping around the cloud band spiral. So it is very nice to see also the development of the rapid cyclogenesis on the water vapor 6.2 microns. Also, we have done some vertical cross-section of the storm Ciarán, and it shows some typical appearance for rapid cyclogenesis. So let's look firstly at the potential vorticity. So potential vorticity shown an anomaly protruding downward to deep into the troposphere. So the lowering of so-called dynamical tropopause is already seen in the initial stage, where the tropopause height sinks below about 400 hectopascals, and in mature stage below 500 hectopascals, in extreme cases below 700 hectopascals. In our case, if you look at the vertical cross-section, you see here is 2 PV units, so it protrudes to around 500 hectopascals. So we really have one of the very, very strong process. Also, you can see some typical appearance if you look at the temperature advection vertical cross-section. So here you have a pronounced cold-warm dipole, as you can see here. So here you have actually the maximum of warm advection within and ahead of the cloud head, and of course cold advection directly behind it. So it is more pronounced than in classical wave. This warm and cold dipole. And what is very interesting to look is the typical cross-section of the isotach. So of course maximum, the first maximum is here at the rear edge of the cold front. But what is very interesting that in the mature stage of the cyclone, you can see that the vertical cross-section of isotach show very high wind speed, also just near the surface. That can be also the sign of so-called sting jet. So let's look here just briefly on the Airmass RGB. Here maybe we can see something that look like this line that can be produced by the sting jet. So the sting jet is actually concentrate on some smaller, relatively smaller region, and lasts for several hours. But this is very extreme phenomena, and it really causes devastating, actually very strong hurricane like wind. Okay, for the end, I just want to show you that very nice, actually, in Airmass RGB of this cyclone Ciarán that is overlaid with mean sea level pressure. So you can see how low the cyclone, how deep the cyclone was. In the center of the cyclone, the pressure was around 950 hectopascals. So very deep cyclone, and it really brings a lot of extreme, severe, and unfortunately dangerous weather, especially in the southwestern part of Europe. So with that, I want to finish for today.